trying to find the area in between curves. And my iPad seems to be broke, so we're doing it sideways. The two curves that they give us is y equals x minus 2 squared. Now, we're doing the nice ones. When I mean nice, I'm talking about the ones that everybody knows how to graph. So then here we go. The other one's a line. But you're like, whose line is it anyway? And let's go see. Boom! I'm graphing that first one. My y equals x squared minus 2. It's a parabola shifted right 2. Ooh. And then I want to go and I want to graph the other one. Oh, it's a line, and I know y equals x is the same as x equals y. I don't know why. I wrote it that way. Now, we need to determine which orientation we're going to integrate. Do we want to do it with respect to y or respect to x? We want to do it with respect to x. So we draw our rectangle in there so we don't wreck our integral. Come on, Ralph. What's the upper and what's the lower, and why did we do it in this orientation? We did it in this orientation so that we could handle this problem with one integral. There's always a top and there's always a bottom. So then our upper, is that how I spell upper? Yeah, what's upper? Our upper is y is equal to x. Why? Because it's on top. Then our lower is y equals x minus 2 squared. Very nice. Now that we got our upper and our lower, we can go and we can set up our integral. So let's go back, way back. Now I have an upper, boom, whoa, wait. Let's go back there, because we're going to need our limits. Our limits, what? How are we going to get our limits? We're trying to see where they are at the same time, so we want to know where they're equal. So I'm looking for this, and I'm looking for this, and I want to do it without guessing. So, I got another yawn, Cassie. I'm going to set them equal to each other. Sure. And that's what's happening here. I'm going to go x minus 2 squared is equal to x. Why? Because I was trying to find the x values where they're equal. Now how you gonna go and do that, huh? We could take the square root of both sides. Yeah, sure, that'd be radical. But why don't I multiply out this left-hand side, get it all to one side, and see if I can factor back. So this is x squared minus 4x plus 4. Where'd the minus 4 come from? It's the first one squared, then the first one times the last one, double it, and then it's the last one squared. We are multiplying out a perfect square. Back that math up. How many times I gotta tell you? Bring that x on over. So we subtract an x, and then I got our minus 5x plus 4. That's equal to 0. How could you even yawn in this class? Eddie got a yawn. Some more. Oh, back to Eric got a yawn. Okay, people. Here we go. Here we go. I'm trying to factor. Teach me how to factor. I tried. I'm looking for the factors of 4 that add to be 5. So you got to get that 4 and 1, x and x. The signs are the same, and they're both negative, negative. So what are my x values? 1 and 4, and that's why we're going to go and we're going to integrate from 1 to 4 of our upper minus our lower. Why so dramatic? 1, 4. Upper, what's upper? X minus lower, x squared minus 2. Oh, yeah, look at that. Get out of there. You don't belong in there. Get up there. Deuce. And we're going to do it with respect to x. That's where our rectangle goes. Now to do this, I guess we could get fancy. I'm so fancy. But let's not. Let's multiply that out and pretend they're all polynomials. I wish they all could be polynomials. And then that's x squared. This one times that one, double it. Minus 4x. What happened to that x? I don't know. Ooh, how do you do? It's a crazy 4. Let me clean that up. Yeah, so that it's not so ew. Before you turn this off and say, I can't. 1 to 4, that's gonna be a minus x squared. Minus and minus make mas. 5x. Then that's a minus 4. Sure. dx. I heard more yawns. I didn't see where it came from. Could be you, the viewer. Okay, so here we go. Yeah, that's minus x to the third over 3 plus 5x squared over 2 minus 4x. Church. Preach. It's upper minus lower. We're using the fundamental theorem of calculus to find the area in between those curves, and we should probably get in here real tight. Minus 4 to the third divided by 3. Somebody pound this out so that when I'm done writing this, we have an answer. Plus 5 times 4 squared over 2. Then, minus 4 times 4. And then that's all minus. Ooh, this is going to be real tight. Bam. Minus 1 to the third over 3 plus 5 times 1 to the third over 2. Oh, tacky. Hopefully this answer sticks.
Is it square?
That's a square. I got so sad that we're running out of room. Yeah. Boom! Do I have anybody in here? Adam? I don't know. What do we get? Adam. Did anybody pound that out? I'll do it. Freaking. Oh no, those are fractions, man. Finish him. Yeah, finish him. Now that we edited out that long pause, it's 9 halves. Psh. Woo, there's a 2. There's a 9. Fine. Woo. Box and flower. Dirty.